So in rhesus incompatibility, you can see that the child that will be affected will be the second pregnancy. Why? It's because in the first pregnancy, the child with a rhesus positive in a uterus of the mother who's rhesus negative. So during childbirth, this is a time where you have mix-up of blood. So red blood cell from the fetus can move into maternal circulation. Then it will take about 90 hours for this mother to develop an immunity against the red blood cells. Because you know you're talking of cellular mediated immune response that will take much time. So by the time she's developing that immunity against the fetal blood, the baby will have been born. So the first pregnancy is not affected. Then after that, in between pregnancies, you find that the antibodies within the mother will be so much, just waiting for those red blood cells. So because now you have these pockets of antibodies against the rhesus antigen. So if she gets pregnant again with a rhesus positive baby, this baby will have rhesus blood with the antigen D on the red blood cells. Then the mother has already produced a lot of antibodies against the antigen D, and these are IgG. They are smaller enough so they are able to cause a placenta to go to the fetal circulation, then it will go and attack the fetus. In terms of prevention, so this can be prevented by giving anti-D antibodies to the mother after childbirth. So you're giving anti-D antibodies. Why? It's because after the first pregnancy here, so before that time whereby the mother will be immune, which will take about 72 to 90 hours for it to develop, you'll find that if you give the antibody or the antigens will be able to destroy the red blood cells or the fetus before the mother is immune. So the mother won't be aware of the fetal red blood cells because of the external source of these anti-D antibodies that you've given. So she won't be immunized. So she won't develop antibodies against the fetal blood because they will be destroyed before that happens. So you find that you can also have another child with a rhesus positive without these antibodies because that will be prevented because of giving of anti-D antibodies. And sometimes you can do intrauterine transfusion, intraperitoneal transfusion to the baby. Once you know to say that there is that risk of having this incompatibility, rhesus incompatibility. Okay, so this is where now this diagram is just summarizing what will happen within the fetal circulation. So you can see that if the antibodies are going to the fetus, they're going to attack the red blood cells of the fetus because the antibodies, they're going to attach to the D antigen. Then the spleen will be able to get rid of these complexes. Then you have a lot of hemolysis. Then out of hemolysis, you have hemoglobin. This hemoglobin, you have indirect bilirubin. This indirect bilirubin, then it will cross the placenta to go to the maternal circulation. Within the maternal circulation, you have the maternal liver. Within the maternal liver, you have an enzyme, glucuronidase transferase. This glucuronidase transferase is an enzyme that will conjugate the bilirubin into conjugated bilirubin, then it will be excreted. So the indirect bilirubin to be converted into the direct bilirubin, which is harmless, and then it will be excreted. This is taking place when the fetus is still in the uterus of the mother. But what happens after birth? This is where jaundice comes in. So the jaundice will start showing. Why? It's because the same antibodies, they are attacking the red blood cells of the fetus because they have the D antigens, and these are antibodies against the D antigen. So the antibody-coated cells will be removed by the spleen. Then you still have the hemoglobin that is coming as a byproduct of hemolysis. This hemoglobin, you have indirect bilirubin. So you have the hemoglobin that will be converted into indirect bilirubin. This indirect bilirubin now they can't cross the placenta to go to the maternal circulation where you have this enzyme, gluconeotransferase. So in the fetus, this organ is still developing, and at this point, you still don't have these enzymes. The gluconeotransferase is absent in the fetal liver. So you can't convert this bilirubin into the direct bilirubin. There is no conjugation of bilirubin, and then this bilirubin now will change the color of the tissue, especially the skin. The skin will start looking yellowish. Why? It's because it's not being converted and then it's not excreted. So this is how jaundice will develop. Then you have the severe case of jaundice, which is called kernicterus. And this kernicterus can result into permanent mental impairment or damage to the motor areas of the brain because of precipitation of bilirubin in the neuronal cells. So you find that the bilirubin, the indirect bilirubin, which is harmful, it can migrate into the brain cells. Within the brain cells, it will precipitate and then it will destroy the neuronal cells. And then that will bring about other clinical signs, the neurological clinical signs in jaundice because of this bilirubin that is precipitating within the neuronal cells. Okay, thank you very much. That's the end.